13, 1, 3, 15, 1, 5. Fitting. I told you to skip 15 because the question got cut off. There's no numbers there to arrange. Anybody else? Once? Twice? Thrice? Thrice is a word. It's a super awesome word. I love the word thrice. Huh? Twice, 2 times, thrice, 3 times. No, there is none past thrice. All right, good. Pentice. All right, now, you now know everything you need to know. Now, I know when some of you see that phrase, it makes your insides get a little gushy, and it feels like you're looking over a tall precipice because I'm taking away... What? A precipice is a nice word, but thrice is no good? No. Dihydrogen monoxide. There we go. Which is much scarier sounding. There's a gag that some chemistry teachers like to pass around. Some guy in Sacramento wanted to show how stupid his city council was. So he brought in a big, long thing about how Sacramento City Council should ban dihydrogen monoxide. And he had all this stuff like, in 100% of drownings, dihydrogen monoxide was present. If your dog drinks too much dihydrogen monoxide, it will cause urinary issues. Like, it was all this stuff like that. And the city council was like, damn, son, we better do that. And they said, motion to look into dihydrogen monoxide, which is, of course, water. All right, back to business. Because, of course, as you all know, water is a covalently bonded molecule with 2 hydrogens, dihydrogen, and 1 oxygen, monoxide. All right, so I know you're all scared of dealing with things that without your calculator, but I don't want you to be. So we're going to go through this kind of a back and forth thing, like, you know, at a hootenanny where I sing a line and then you sing the line back, call and response type of thing. Because you don't need me to do all this, you could do it all. But sometimes you'll get to one and you'll all be like, ugh, and I'll all be like, you know how to do it. And you'll be all like, no, I don't. And then I'll be all like, but isn't it like this? And you'll be all like, oh yeah, it's exactly like this. And I'll be all like, so do it. And then you'll all be like, I can't. And then I'll be like, but you can. And then we'll get in a long circle. Well, you can't have a long circle. We'll just get into a circular argument because, of course, a long circle would be an ellipse, I suppose. So let us get back to math. This looks frightening without a calculator. You're all going to be like, yuck, but it's super easy. Why? Why are you going to add the exponents there? Because they're the same base. So that's 0.3 to the what? 2. And of course, you can all do that in your head because you do one of 2 things. One, you remember that 0.3 is 0.3 times 0.3, which gets you 9 with how many decimal places? 2. 1, 2. And what goes in the hole? 0. I, of course, hate that. Why? Because decimals... So, of course, what this really is 3/10 squared, which is 3 squared over 10 squared, which is 9 over 100, which is the answer I would prefer. Yeah? Yeah. That's how this whole sheet works. Okay? All right. Let's do this thing. That should scare all of you. All of you should be a little scared by that, but you don't need to be. Why? Because it's the exact same steps. Because, what do you see there and there? Same base. So what are you going to do there? To get what? Negative 3 halves to the negative 8. Times, what are you going to do there? to the 6th. What are you going to do there? Add them to get negative 3 halves to the what? And what are you going to do there because you see that? Flip it. Now we get to where kids start making mistakes. What happens to that? That stays. Oops, I attached it to the fraction line. What happens to that? That one goes positive. Now what's our answer? No. 4/9. How does this become positive? Because that negative is part of the base. So it has to be squared. Now, that, ladies and gentlemen, in a nutshell, is the entirety of this unit. If you can follow all of those steps, that is every possible permutation of exponent laws that you could ever get. The only thing that would be changed is if there were some x's in there and y's in there as well. If you can do number 2, basically, I could stop and give you your test right now. Of course, that would be stupid because we need the practice. What are we doing there? This should be like a 2-second question. What's the answer?
1.4
to the 9th. Absolutely right. Anybody need to talk about why? Okay. What are you going to do with 3 and 4 up top? Add them to get 1.4 to the 7th over 1.4 to the negative 2. Now, once again, at the very least, I insist you memorize the exponent laws. Those exponent laws are... The exponent laws are kind of like... Remember when you were learning to ride a bike and you had training wheels, and every so often you would actually get riding your bike so neither training wheel was on the ground? And you were like, oh my God, my training wheels aren't making any noise. I'm actually riding a bike. And then as soon as you did that, you looked back at your parent, grandparent, auntie, uncle, brother, whoever was teaching you to ride the bike, and immediately you started to lean over and make the clickety-clankety noise from your training wheel. Or worse, you crashed because you weren't looking where you were going. The exponent laws are the training wheels. You can always fall back on them to save you if you don't know what is really happening. However, there's 7 of them, which means 7 given paths at any given moment, and that can confuse you. So you are better off to, of course, learn what is actually happening. What does that negative 2 do to that 1.4? It reciprocates it up to the numerator, where I already had 7 1.4s, and now I have 2 more. Which means I have 1.4 written 7 times, which I'm not going to do. 1.4 written 2 times, which I'm not going to do, to get a total of 1.49 times. Now, if you are relying on the training wheel method of learning this, of course, you subtract the exponents, whatever they look like, 7 minus 2, which is, of course, 7 plus 2, which is, of course, 9. Now, the problem here is if you rely on those training wheels, when I give you this, 1.4 to the 3 to the negative 3 over 1.4 to the 7th, here is where you start to screw up if you follow the training wheel method. Because you will go negative 3 minus 7, get negative 10, and forget that what really that is 1.1 over 1.4 to the 10th. Because really, if you really know what you're doing and you actually pay attention to all the stuff on the left side of the page when I taught you the exponent laws, which was why they all work, the more important side of the page, you will notice it took up 3/4 of the page to tell you why it worked. Then I could put the rule in this much space. It's a good use of a good judgment thing in math class. if the rule takes up that much space and the explanation takes up the rest of the page, spend a lot more time with the explanation. Because, of course, you would bring that down there. Right? And then the corollary of that, or the next logical step, is if this was a negative here. Then you'd have negative 3 minus minus 7, which is positive 4, and then positive 4, is it on the bottom or is it on the top? I don't, right? Know what's really going on. And this one, 4. 4 is slightly more difficult. Why? Rational exponents. Does anything change? Of course not, because they're all the same base. So what are you going to do in the denominator there? And what is 1/3 plus 5/3? 6/3. Now some of you right away, because you're remembering this is bad crumble, are going to go 6 divided by 3, that's 7 squared. Got it, Myers. But that would be a bad thing to do. Why? What do you see right there? Same base. So what do you got to do with those exponents? You got to subtract. And if you make that 2, then you just got to bring it back to 6/3, don't you? Because to subtract 7 2/3 minus 6/3, didn't you need the same denominator? And you had it. So it is 7 to the what? Negative 4/3. Now, we're in trouble again. What do you see there? So what does that do to this?
Makes it over 1.
It's already over 1. It reciprocates it to get 1/7. And you could put the 4/3 down there. You could put the 4/3 up here. Or the best answer is out there. That is exponential form. The last lesson taught you another way to write this, which would be, of course, what? What would you do with the 3? Cube root of 1/7, because the base becomes the radicand, to the 4th power. They are the same thing. You need to be able to work with them both. Of course, this is also 1 over the cubed root of 7 to the 4th. And, of course, it is also 1 over the cube root of 7 to the 4th. And it is 1 over 7 cube root 7. All of you are aware of why that one exists, yes?
Because the 4 7.
There were 4 7s right there, yes? One group of 3, leaving 1 under there. You need to be able, not necessarily to work with them all, but you need to know that everything I just highlighted green is the same thing. Okay? Excellent. You should be able to do 5 and 6 in about 2 seconds. Go. Yo. Sorry, what? Good? Neither one of those should require too much explanation. We good? Yeah? Pardon me? Okay, again, if you go with the exponents, what should you do with 2 and negative 4? You get y to negative 2, right? Okay, are negative exponents allowed? No. So where does just that have to go? It has to reciprocate. Right now, it's y over 1. It reciprocates to x to the 5th, 1 over y squared. X to the 5th times 1 is x to the 5th. X is over 1. 1 times y squared is y squared. Now, the other way to look at that is this way. That is x cubed, x squared, y squared, all over y to the negative 4, right? Or sorry, y to the positive 4, because when we move it to the denominator, it loses its negative exponent, right? And now, 2 up there, 4 down there, cancel those 2, and I'm left with 2, and then x to the 5th over y squared. Now, I am not saying that you have to see all of these permutations the way I see them. Like when I look at this, I can see it in all 3 of these at once. You don't have to be there, but you have to understand for you what works. Yeah? And everyone's okay with 6, right? Because, of course, that negative 2 would come up to the top, and there were already 3 there. Right? Okay. 7 is no problem. And then 8 gets weird. What is it for 7? 1.5 to the 10th. Right? Now, of course, that is also 3 halves to the 10th. That is also 3 to the 10th over 2 to the 10th. All kinds of things we can write there. But it's an exponent unit, so I am most concerned about the tens. Right? Okay. What's weird about 8? The exponent on the outside of the bracket. Now, if it were a 3, what would we do? We'd bring it in, and I would get what? 8 cubed, a what? 6? A to the 9th, b to the? Excellent. But it isn't. It's a 1/3, so it's not a to the 3rd, it's a to the 1/3. And it's b to the what? No. 3 times 1/3. 3 1/3, which is what? 1. And it wouldn't be 18, it would be 6 times 1/3, which would be 2. So I would have 8 to the 1/3 ab squared. One of those makes no sense. Which one? 8 to the 1/3, because of course you cannot write it out. You cannot write 8 times 8 1/3 of a time. So we have to rely on our knowledge, which says to us that this is the cubed root of 8, which is what? 2ab squared. Now, you could also have done this way. What's the base? No, what's the base in number 8? 8a cubed b to the 6th, yes? Okay, so if that's the base and it's got that exponent, isn't it cubed root of 8a3b to the 6th? Okay, what's the cubed root of 8? 2. Out comes a 2. Cubed root of a cubed. How many groups of 3 can I get out of there? 1. How many groups of 6? How many groups of 3 can I get out of 6? And there you end up with the same answer. Who decides how to approach the question? You do. The only way to become confident in your decision, in your approach, is to practice it. Because otherwise, I get this. What should I do here? Multiply the exponents? Which is a question. I am asking the questions. What do I want from you people? Answers. Look at 9. Why is it weird? What's weird about it? You should say nothing. Because isn't that just 4 divided by 2? And isn't that just a negative 2 over a squared? And isn't that just b to the 2/3 over b to the 1/3? Oh, what's 4 divided by 2? 2. Where does that have to go? Down there, which means it's gone, so I'm over what? And what do I do with those exponents? There's 2/3 on the top and 1/3 on the bottom. So can I cancel that and cancel one of those to leave me with b to the 1/3? Is that okay? Yes, that is exponential form. But does that make a lot of sense? No. So what would we change it to make it look prettier? 2. Everybody good? Because, of course, that takes us back to that and knowing what everything is. Yeah? All right. Let's look at 10. And I'm going to actually ask you, even though I never ever do this, I want you to do number 10 in 2 different ways. You may work together, I do not care. You may do one way, your friend may do the other way, and then you may copy each other, which is probably what is going to happen. But go. There are more than 2 ways to do this. I just want you to practice 2 different ways. 20 minutes to do one question? 3? Challenge accepted. I think 3 is a long time, though.
3 minutes?
That's what RJ says.
No, RJ, stop. Stop. 3 minutes was enough. No, I'm like dumb, bro.
Hey, it's Orange Shirt Day. We care if she's dumb. See what I did there, Jewel?
No. I'm confused. Does the Orange Shirt thing have something to do with Aboriginal students and residential?
It has to do with bullying as well.
Okay.
It's all tied in together.
Actually, it is a
Oh yeah. That makes sense. You can do that same thing and just make B 2 or 4. B. Yep. Got it.
Alrighty. And there's the gong. I know. I was so happy when I watched the first game and I heard a gong at the end of the first half. Rugby World Cup. Shut up! I'm already sad about it. You were going to say I can't believe Japan beat Ireland. But you shouldn't be sad about it. Japan has always been giant killers. They beat South Africa last one. They almost beat Scotland last one. Everybody was surprised. Ireland's the number 1 team in the world. A squared.
No, it's not that you're writing it. I'm not very bright.
All right, please notice. One way in black allows you to break it down and do very elementary math, right? The way in blue requires you to know a bit of stuff about what's going on, like especially this part in the middle here, where you end up with 2a to the 5th. So you brought out a squared and you were left with square root of a over square root of a, which allows you to cancel. And then this one, the square root of b to the half, that's the square root of a square root. So obviously that's a 4th root. Right? Everybody good? All right. Now, I want you all to... what the heck? Is your 13 written there? Yeah. Fidger. One time, this is a funny story. On one of your upcoming tests, I'm going to give you a question, and the question is going to say, explain your work. Now, wait a second. I used to give this question, and no kid would do it. They wouldn't do any explanation. I took away like 4 marks. They'd be like, why are you taking away marks? You can see I know how to do math. No, I can see you can follow steps like a trained monkey. I want to know if you can actually explain it. And the kid was like, you're a dick. I was like, tell me something I don't know. But then, the next year, I changed the instructions. And the instructions say, pretend like you are me, and you are teaching somebody who knows nothing about math how to do this question. Explain your work. And every kid then did it perfectly, but one kid took the pretend you are me to heart. And he started writing all the work, and every so often he'd scribble something out and write arg, or face palm, or garrah, and then he'd scribble it out, and then he'd write the right thing. I gave that kid bonus marks. No, now you can't, because he's already done it first. But it was super funny. I was marking, and then I started laughing, and everyone's like, what? And the other kid was like, the kid that knew what had happened. It was super funny. Anyway, now... I have stopped here for a reason. And you're all going to say to me, when I accuse you of what I'm about to accuse you of, you are all going to do that teenager thing and say, no, I never would have done that. So, all of you, as soon as you see this and this, are going to write this as -2 to the 3 halves, 3 squared, times negative 2 to the 1/2, 3 to the negative 1. And then you're going to be like, okay, well, 3 squared is 9. Oh, I don't know. Negative 2 to the 3. And you're going to get out your calculator. You're all going to do it. Don't lie to me. I've been teaching math for 21 years. Of course, what should you do first? Connor?
You just work with the x's and the y's.
You would just work with the x's and the y's. Because, of course, if you took one more second, you would notice that 3/2 and 1/2 is x to the 4/2, which is x squared. And then you would notice that 2 plus negative 1 is y to the 1, which is just y. And now it's negative 2 squared times 3, which is what? 12. Right?
Yeah.
Right. Now do 12. Go.
Do 12 and kind of control
Are we putting in the negative 2
You do what you need to do.
for 12 too?
Yeah, x is negative 2, y is 3. Go. Now, I will tell you right now, that exponent is going to be very, very large. So if you just get to the point where you have a base and an exponent, I'm happy. I like your confidence, Connor. That should work. A great many things in the world have been accomplished because somebody said, that should work, and then it did. Should that work?
Garbanzo beans.
Do you say garbanzo beans instead of chickpeas?
No.
I say chickpeas,
I say
even though garbanzo beans is way more fun to say.
I say garbanzo beans. Sometimes I forget the garbanzo beans are the same.
Ah. Garbanzo beans is more fun to say. All right, let's hear some answers. What do you got, Connor?
Negative 2 to the 20th.
Negative 2 to the 21st. Do I have anybody else? Now, how many people who don't have that think they're wrong right now? Why would you think that? Maybe Connor didn't do it right. Connor, stay cool. Maybe you did do it right. Relax. No, stop. That's the whole point.
Here's what I
What do you got, Jewel?
negative instead of brackets to the okay. Bracket that. Put a negative on the outside. It's power 84.
Interesting. Tamana, please. Tamana. Negative 2 to the 48th. Armand. Negative 2 to the 12th. What else? Vicky. 4 to the 34th. Okay. All right, now, ladies and gentlemen, how is it possible that we have 5 vastly different answers when, what do we call the things that we are applying here? Exponent laws. How can we have 5 vastly different answers? Because ain't no 2 of those answers anywhere near each other numerically speaking. I mean, they're kind of close. They've all got 2's and there's some negative signs and there's some exponents. Well, no, because 4 is just 2 squared, right? Okay, so let's talk. Because this one is tricky on purpose. All right? Now, when I erase, that number 13 is going to come back. But what are you going to do? Yeah, there it is. Ignore number 13. Pretend it's not there. So, where is something you could see to attempt to tidy this mess up? Who wants to give me a spot to start? Connor?
Put the 3 on the outside of the brackets into the 2 4s.
That 3 goes to the 2 4s. Is everyone okay with that? Okay. Now, Connor, why didn't you bring it to that 3? I'm not saying you're right or wrong. I'm asking you, why did you specify? Please stop it. Or you're welcome to come up and take the pen and do this, because you were both wrong too. Okay? Why did you specify the 4s?
Because the 4s are on the outside of the other brackets.
Okay, so you're saying that this is its own base, and I'm only dealing with that 3 now. So your first step would be x to the 12th, bracket, negative x cubed, bracket, all to the 12th.
Yeah.
Are we happy with that? Now, even if you didn't do that, do you see why Connor did that? Okay. What would be... What? Sorry? Okay. Let's pretend none of that was there. What would you do with that 3 and that 4? And I would get x to the 12th, yes? Okay, now let's pretend that wasn't there. And this was just, let's say it was just a pink square or a pink rectangle. What would you do with that 3 and 4? You would have pink rectangle to the 12th, yes? All right. But it's not a pink rectangle. It's negative x cubed to the 12th. Are you happy? You happy? Okay. Now where do you see something you could get rid of? You would want to deal with that? Okay. X 12th. Is that negative part of this base? Yes. So if I do that to the 12th, what will happen to that negative? Why will it be positive? Because it's a negative in a base to an even exponent. So this will become x. Oh, why? It was doing so well. Why? Now I can't even erase all that because it won't select it. So now what would I have? X to the 36th. Old school. Because you know what always works? Analog. Whoa. All right. X to the 36. Now what do you want to do? X to the 48. Now what do you want? Now it's as simple as it's going to get, right? What is x? Negative 2 to the 48th. Is the negative part of the base?
Yes.
Is it an even exponent?
Yes.
So what's the answer? 2 to the 48th.
Yeah. We still got it right.
A big number. Let's find out what 2 to the 48th is by going 2 y to the x 48. 44 48. It is 2.84814749767 to the 14th, which means that decimal will move 14 places to the right. It will cover 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those spaces, and then 4 more. is a big number, right?
I could probably get it if I did times 2 and not times.
Now, why would I give you this with a negative base and then have a negative out here? Because this is when you have to see that you also need to understand what is happening. Not just multiply over brackets, add same base, subtract division. Okay? You're not trained monkeys. You are very intelligent young people. You must know what is going on as well. All right? Now, every time I say that, I'm getting less and less laughs back from you. That makes me very happy. I do not want you to laugh when I call you very intelligent young people. If I wasn't serious, I wouldn't say it in that normal tone of voice. Obviously, sometimes I say things I'm not serious about in weird tones of voice, so you know that I am not serious about them. Right? Right. Now, let's see. It's had a nice long break. No. Whatever. Screw 13 and 14. I don't care. Give me your book. I don't even know where we are now because I can't even make the screen slide. All right, so listen up. Page 62 and 63 go very far out of their way to get you to a point where when you try the review, which begins on page 65, you will get 40 out of 40 or whatever that review is worth. I can't remember. If you have practiced 63 and 65, that review will be, 61 and 63. That review will be a walk in the park. All right? But if you go straight to that review without at least looking and trying a few questions from 61 and 63, eventually you are going to get to a point where you have to ask me for help on the review. Now, that review is an assignment, which means it is being used to assess your understanding of math, yes? So, should I be showing you what to do on a review? No, because you have each other and your textbooks and your notes to do that. Now, some of you will hear what I just said and say, you will go home and you will say, Mr. Myers won't help me do my work. I know this because, again, I have been teaching for 21 years. Of course, that is not true. I have helped you do your work because you have every piece of knowledge you need written in your book, if you've been writing it down, to do every question on the review. Right? Right. And every day I ask numerous times if everybody's okay. Right?
Yes.
Right. And every day I face a wall of cricket sounds when it is time for you to ask those questions. Until I say, do this review. And then all of a sudden, oh, Mr. Myers, Mr. Myers, Mr. Myers, Mr. Myers. Right? Now, when you do that, there are 30 of you and there is one of me. I cannot get to all of you. Right? So use your brains. At least you need to have a very good look at 61 and 63. At least a look. I don't care how much of it you do because, again, the answers are there. Obviously, you're all going to get all the right answers because the answers are written there. All right? I cannot force you to do any amount of homework, so I don't. Go.